Hello my dear students, in this video we are going to discuss second model of inventory management, that is known as economic order quantity model with price breaks. In previous videos we have discussed that there are certain assumptions of classical economic order quantity model. These assumptions should be fulfilled to apply classical economic order quantity model for the purpose of inventory management. These assumptions are as follows. Demand is certain, continuous and constant. Lead time is known and fixed. Carrying cost and ordering costs are constant and independent of the quantity ordered. The purchase price is constant. Inventory can be refilled instantly and completely in a single batch in a single point in time, and there are no stock overages or shortages. So to optimize any inventory situation, if you want to apply classical economic order quantity model, then these assumptions should be fulfilled. But in real life, there can be some situations in which these assumptions or some of these assumptions cannot be fulfilled. To handle those situations, we need to incorporate some modifications into existing classical economic order quantity model. In this video, we will discuss about a situation in which the fourth assumption, that is purchase price is constant, is not fulfilled. It means the purchase price is not constant, or there are quantity discounts available. In real life, it is very common to find price discounts if we place an order for larger units or for larger number of units. In these type of situations, different prices are quoted for different ranges of order quantity. So in these situations, the quantity ordered need to be determined very carefully by keeping in mind the different price levels for the different quantity ranges. In case of classical economic order quantity model, in which all the assumptions are fulfilled, the decision makers focused on minimizing the annual variable inventory cost. That is, the total annual inventory cost is equal to ordering cost plus the holding cost. In situations of classical economic order quantity, the purchase cost becomes irrelevant while determining the order size, because purchase cost is considered constant. So the focus of the decision makers remain on minimizing the annual variable cost, that is denoted by ordering cost and holding cost only. In that case, we used these formulas to calculate the optimal order quantity and to calculate the annual inventory or annual variable cost. But in case of economic order quantity model with price breaks, the purchase price of the units become very relevant while determining the order level, because the purchase price changes with the quantity ordered. So in this model, we need to consider three types of costs. First one is the total ordering cost, as we considered in classical economic order quantity model, and total carrying cost, and third is the total purchasing cost. So in this model, we would consider all these three costs to determine the optimal order level, that is economic order quantity. In short, we can say that we would opt that order level which minimizes the sum of these three costs. The sum of these three costs can be expressed by this formula. That shows that total cost would be equal to ordering cost, carrying cost and purchase cost. So in this formula, Q denotes the number of units in each order, D denotes the annual demand in units, A denotes ordering cost per order, H denotes the holding cost or carrying cost per unit per annum, and C denotes the per unit purchase price. So in this model, we are going to use these variables or terms to calculate the total cost, and on the basis of total cost, we would decide that which order level we should opt so that we can minimize the total cost of the inventory. In these type of situations, the purchaser or the buyer can get single price break or multiple price breaks. As this is the formula of calculating the total cost, where C denotes the purchase price at different order levels or at different quantities ordered. Like C0 denotes the purchase price if the quantity ordered is less than a particular quantity that is equal to Q1. Similarly, C1 denotes the purchase price if the quantity ordered lies between quantity equal to Q1 and quantity equal to Q2. So the order level should be less than Q2 but greater than or equal to the Q1. Further, C2 denotes the third price break that would be given if the quantity ordered lies between Q2 and Q3. It means if the quantity ordered is less than a particular quantity Q3 and greater than or equal to a particular quantity that is equal to Q2, then the buyer would get the C2 price break or would get the delivery at this price, and so on. These price breaks can go up to n-1. So while dealing with such type of situations, always remember that to calculate the total cost, we need to consider ordering cost, holding cost, and purchasing cost as well. So to understand it in a better manner, let's have a practical question in which a company procures hardware items of which the expected annual sales equal to 8,000 units. Ordering cost is 180 rupees per order. Holding cost is 10% of the average inventory value. And there are different price breaks are given. Like if the quantity ordered lies between 1 to 999, then the unit price would be equal to 22 rupees. If the quantity ordered lies between 1000 to 1499, then the unit price would be equal to 20 rupees. So we would get a discount of 2 rupees per unit. Similarly, third case, we would get the unit price equal to 19 rupees if quantity ordered lies between 1500 to 1999, and if the order level is equal to 2000 or above 2000, then we would get the delivery at the rate of 18.5 rupees per unit. So with this information, we need to find that which option or which price break we should adopt. So let's consider all the available options one by one. So it is the first option in which the lot size is equal to 2000 or above 2000. In that case, the per unit cost or per unit price would be equal to 18.50 rupees. Holding cost that is given 10% of the unit price, that is equal to 18.50 in this case. So H would be equal to I into C. It means 10% into 10% of the 18.50, and it would be equal to 1.85. A is constant, that is equal to 180 rupees per order, and quantity demanded is equal to 8,000 units. So with this information, we need to find the total cost if we order 2000 or above 2000 units in a single order. We can calculate, first of all we need to calculate the economic order quantity for this particular situation. That can be calculated by using this formula, by putting all the values given here in this formula. 2 into 180, that is equal to A, D 8000, and H, that is equal to 1.85. So the answer or economic order quantity is equal to 1248 units. Now remember that this solution is not feasible, or this economic order quantity is not feasible, because unit price of 18.50 is available only in that case in which the order size is greater than or equal to 2000 units. But in this case order size is equal to 1248 units. So this solution is not optimal, or it is not optimal to order 1248 units in a single order, because in that case we would not get the unit price equal to 18.50. So to determine the total cost, we would consider the cutoff point. So in this case the cutoff point is 2000. As you can see here, the cutoff point in this case is 2000 and above. So we would consider the cutoff point that is equal to 2000 to calculate the total cost. For that purpose we would consider 2000 as the economic order quantity, and in place of Q we are going to use 2000. So when the economic order quantity is equal to 2000, then what would be the total cost? By putting all the values in this formula, D by Q, that is D is equal to 8000 and Q we have considered equal to 2000. A, order per cost per order, that is equal to 180 rupees. Average inventory, that is Q by 2, 2000 by 2, and H, that is equal to I into C, that is equal to 1.85, and plus CD. C denotes the cost per unit or per unit price, and D denotes the demand, annual demand. So after simplifying this formula we would get total cost that is equal to 1,50,570 rupees. In a similar manner, now we would consider the option 2, in which the lot size is equal to or is between 1500 to 1999. In that case we would get unit price equal to 19 rupees. H is 10% of 19, as the unit price in this case is 19, so H would be equal to IC. So the value of H would be 1.9 per unit per annum. A is fixed, that is 180 per order. D is fixed, that is 8000 units. So to calculate the economic order quantity, again we would apply the standard formula and we would get the answer that is equal to 1231 units. Now again this solution is not feasible, because to get the unit price equal to 19 rupees we should order at least 1500 units in a single order, and economic order quantity is suggesting that economic order quantity should be equal to 1231. So in that case we are not going to get the unit price that is equal to 19 rupees. So again, if the solution is not feasible, then we would consider the cutoff point of the given range. So the cutoff point of the given range is 1500 units. So to calculate the total cost, we would consider 1500 as the economic order quantity. So by putting all the values in the formula, we would get the total cost that is equal to 1,54,385. If you have noticed, in the previous case we have ordered 2000 units in a single order and the total cost was equal to 1,50,570. In this case the order quantity was lesser than the previous case, that is equal to 1500 units, and the impact on total cost was that the total cost was increased from the previous level. It is equal to 1,54,385. In a similar manner, we would consider the third option that is available to us, in which the lot size is equal to 1000 to 1499. If we order in this range, then we would get units at cost price of or purchase price of 22 rupees per unit. In that case, holding cost would be equal to 10% of 20, that is equal to 22 rupees, 2.0 rupees. Ordering cost is fixed, 180 rupees per order, and so is the demand, that is equal to 8000 units. So by applying the formula, we would get economic order quantity, that is equal to 1200 units. As this value, that is equal to 1200 units, falls in this range, as the value 1200 falls in this range, that is 1000 to 1499. So this solution is feasible. So we can opt this economic order quantity to calculate the total cost of the inventory. So by considering 1200 as the Q or economic order quantity, we would solve this expression to calculate the total cost. By putting all the values in this expression, we would get the total cost, that is equal to 1,62,400. So you might have noticed one thing while solving this situation, that smaller the order size, larger would be the total cost. If the order size is smaller, then the total cost would be larger. In this case, the order size is equal to 1200 units and the total cost is equal to 1,62,400. In previous case, the order size was equal to 1500 that we have considered, and the cost was smaller than the previous one, that is 1,54,385. And if the order size is equal to 2000 units, then the total cost is equal to 1,50,570. So there is a trend. If we increase the order size, we would get smaller total cost. So in this particular situation, if you consider the smaller order size, the total cost is going to increase. So on the basis of our calculations or economic order quantity model with price breaks, we can say that the optimal solution in this situation is 2000 and above. So the order quantity should be equal to 2000 and above to minimize the total cost of the inventory. So in this way, we can apply the second model, that is economic order quantity model with price breaks, to minimize the total cost of inventory. In next videos, we would discuss other models of economic order quantity or inventory management. Thank you.